Welcome back, everybody. In this video I will be going over the quadratic formula. First we want to talk about what the quadratic formula is, then why it is useful and when to use it, and then finally how we actually use it. So let's get into what the quadratic formula is. If the quadratic is written in the form ax squared plus bx plus c equals 0, then we can use this to solve for x. This is the quadratic formula right here. X equals negative b plus or minus the square root thing. All of this is inside b squared minus 4ac all over 2a. Now, to just quickly recall something from the last video about simplifying square roots, you can see exactly why you would need to know how to simplify a square root, because it is a part of the quadratic formula. And one other thing I want to bring up very quickly is this equation right here. In previous videos, I have called this the standard form equal to 0. And we wanted this form for factoring, and we also want it for the quadratic formula. There's a slightly different form I'll go over in a future video for when we want to use either completing the square or the square root property, but we'll get to that when we get to that. Let's get into why this is useful and when you know to use it. So these two questions on this slide, why is the quadratic formula useful, when should you use it, are pretty straightforward. So the quadratic formula is useful because it solves all quadratic equations, like all of them, every last one. It doesn't matter if there will be imaginary roots or real roots or whole number, fraction, square root roots. It solves all quadratic equations. As for the second question, when should you use it? You should use it when you can't solve a quadratic equation by any other method. So if you try factoring and it does not work, you should use the quadratic formula. If you try the square root property and it doesn't work, you should use the quadratic formula. If you try using the completing the square and it doesn't work, you get the idea. Let's take a look at some examples. How does the quadratic formula work? Well, there are three basic steps, and they kind of follow the similar idea of what you learned in the factoring video. You want to first make sure you have standard form equal to 0. If you do not have this form of an equation, then you will not be able to use the quadratic formula. The second thing I like to do is actually identify A, B, and C. So A is here, B is here, C is here. And we have these numbers for A, B, and C. And then all I have to do is substitute these numbers into the quadratic formula. So here is the quadratic formula again, negative b plus or minus square root of b squared minus 4ac all over 2a. And all I'm going to do is substitute these values for a, b, and c in for a, b, and c into this formula. But I'm going to write this down one time so you can see how I do this in my head, if you will. Anytime I have a variable that I'm going to replace with a value, I'm going to put a set of parentheses in its place. 2 times a. All right, so now all I have to do is play matching here. So this first value is going to be the b value, which is negative 2. The second value here inside the square root is going to be a b value, which is a negative 2. And you just continue this process like so. Then what I like to do is to simplify this square root. And we're going to do this all in one step. So this is going to require a little bit of side math, and I'm going to do it right over here under step 3. So I'm just going to look at this square root here, and I'm going to simplify the radicand using the order of operations. So I'm just going to use, see if there's anything inside the grouping symbols I can simplify. That's a real quick no. It's going to be no every time. But then I'm going to follow my exponents and say negative 2 squared gives me a positive 4. And that's the only exponent I have there. Then I'm going to take my multiplication and I will do this. I will say negative 4 times 1 times negative 11 is a positive 44. So 4 plus 44 equals 48. And the largest perfect square factor of 48 is 16. The other factor would be 3, which gives me a final square root of 4 square root of 3, a final simplification. So this 4 square root of 3 is the simplified root of what we have in our formula. So I'm just going to go ahead and rewrite the quadratic formula now with the simplified square root, as well as at the same time simplifying this little expression and this little expression. All right, so here is a final expression. And one last thing that we will always have to be checking for is simplifying the fraction if necessary. And it's super simple to do. All we have to do is check all of the numbers outside of the square roots. So the 2, the 4, and the 2. And we just simply ask themselves, do they have a common factor amongst all of them? And the answer is yes. It'll be 2. So we can divide by 2, we can divide by 2, we can divide by 2. And if you can do it, then do it. So this will leave me with x equals 2 divided by 2 is 1, plus or minus 4 divided by 2 is 2, square root of 3. And in the denominator here, something a little bit weird happens. The 2, when we divide it by 2, will give us a 1. So essentially, we're dividing this entire top half now by 1, which really doesn't do anything for us. We don't need to write that. So this will be our final answer. X equals plus or minus 2 square root of 3. And just for a little bit of foreshadowing, this plus or minus here, this means there are 2 answers. One version is positive and one version is negative. So the positive version would look something like this, 1 plus 2 square root of 3. And the negative version would look like this, 1 minus 2 square root of 3. And this is important too because we are solving quadratic equations using the quadratic formula, which means there's an x squared. And that biggest exponent, that degree 2, is telling us that we should be having 2 answers. And there they are. Before I forget and move on to the next example, I just want to point one other thing out. How does the quadratic formula work? Well, I forgot to check right at the beginning, and I will make sure to do this in the next example. If you just do a quick check, how I teach factoring here, if you just do a quick check of your target product of A times C being negative 11, and your B value being negative 2, and the only factors of 11 that I can think of are 1 and 11, and since AC is negative, one of these has to be negative. In fact, the larger one will have the sign of B, so this will be a negative 11. This is the only possible set of factors we could have for negative 11 in this scenario, but these 2 factors do not add up to negative 2. And when you're solving, you want to check to see if it factors, and if it doesn't factor, you want to quickly move on to the quadratic formula. So as this problem would go, you would get it in standard form equal to 0, do a quick check, does it factor? Yes, okay, then use factoring. If not, if you can't find any values that work here, use the quadratic formula. Let's take a look at that next example. All right, for this example, we want to solve this equation. Negative 2 times the quantity x minus 5 minus 3x squared equals 3x plus 7. This is nowhere near being in standard form, so we need to do that first. I'm going to do a distribution here and get this new equation. Then I'm going to do something that I am going to recall from my factoring videos. Life is just much easier if we have a positive number of x squareds. And right now this is a negative 3x squared. So I'm going to take these three terms and I'm going to perform the opposite operations I need, addition, subtraction, and addition, to move all of them to the right side of the equation. And as I do this step, I'm going to add 2x to both sides, subtract 10 from both sides, add 3x squared to both sides. You can see that the terms that can combine, I'm lining up vertically here. So the minus 10 I know can combine with the 7, and the 2x I can combine with the 3x. So I'm going to do that, and I will also rearrange the terms on the right side as the terms on the left side are all going to cancel. I'm going to write these terms in standard form. So it'll look like this. It'll be 0 equals 3x squared plus 5x minus 3. And of course, this is just as good as having standard form equal to 0. You could, if you want to, rewrite this equation with this on the left and this on the right, but I'm just going to leave it for now because we can easily identify A, B, and C. Once you have standard form equals 0, let's check really quickly, like I said I was going to do in the last slide. Let's check to see if we can factor this, because we don't want to use the quadratic formula if it factors. So this is negative 9, oops, and B is 5. There we go. So I know the two numbers here that will multiply to negative 9 will have to be 1 and 9, and 3 and 3. Those are the only factor pairs I have, and I know one of the two has to be negative because my product is negative, and I know that the bigger term will be positive in this case. Sorry, the bigger factor will be positive in this case because that is the sign of B. So this one will be positive, and one of these has to be positive, which means the other signs, or the signs of the other factors, have to be negative. Let's see, 9 minus 1 is 8, we're trying to get 5. 3 minus 3 is 0, we're trying to get 5. So it does not factor. Let's use the quadratic formula. So here is the quadratic formula. Here's the quadratic formula with all of the numbers filled in. And again, I'm just going to simplify the square root as best I can off to the side here. So the square root of 5 squared would be 25. And then when I look at these three numbers, negative 4 times 3 times negative 3, that gives me a positive, what is that, 36. I can add 25 and 36 and get the square root of 61. And then I have to think, what is the largest perfect square factor of 61? There isn't one. This is as simplified as it gets. Sometimes that's the way it happens. So here we can just substitute the square root of 61 back into the quadratic formula. And then as I bring the rest of this down, I'm just going to do these little simplifications. Negative 5 in front of the square root, negative 5. And in the bottom, it's all over 2 times 3 is 6. Now, I'm just going to highlight with my little laser pointer here. Negative 5 is outside of the square root, 1 is outside of the square root, and 6 is outside of the square root. Is there a number that you can divide evenly into all of them that is not 1? right? Negative 5, 1, and 6. And the answer is no. So this is our simplified answer for the solutions of this quadratic equation that we started with. Now, again, there are two answers here, one positive version, one negative version, so you could write this out 2 times. Negative 5 plus square root of 61 over 6, and the other answer would be negative 5 minus square root of 61 over 6. But for most college, even high school courses, it is okay to leave the plus minus here. Let's take a look at the next example. So here we have another example, and you can see clearly it is not in standard form. So I'm just going to go ahead and put it into standard form. You'll need to perform a distribution here and add 5 to both sides so that you have it in standard form equal to 0. So after you do all of that simplification, getting it in standard form, it'll look like this. So from here, you can use the quadratic formula because this will not factor. Again, since AC is positive, both factors will have the sign of B. 1 plus 25 is 26, not 1. 5 plus 5 is 10, not 1. So this will not factor. So let me get the quadratic formula written here with the numbers filled in. So here we go, there's the quadratic formula again. And again with all of the numbers filled in. But I will take the square root off to the side. 1 squared is 1. And this time it's going to be a negative because I've got negative 4 times positive 5 times positive 5 is negative 100, aka subtract 100. You can subtract those pretty easily to get negative 99. And this is our first and only example. You have a negative in the root, so that should come out as an I. So this will be I root 99. And then we're not even done. We have to check to see if this factors. Is there a perfect square factor of 99? And if so, and if there are even more than one, we need the largest perfect square factor of 99. It turns out 9 is the largest perfect square factor of 99. We can take the square root of the 9 and get 3. The I is still outside, root 11. So we take this whole root and we substitute it back into the quadratic formula that we're going through, 3I square root of 11. It's still plus or minus. Then I simplify these here, negative 1 and 10 in the bottom. And that's what x will equal. So again, we do a very quick check. Can you divide negative 1 and 3 and 10 by the same number? No, we can't do that. So here is our final answer. Again, 2 answers, 1 plus, 1 minus. I've got one more example to run you through. For this final quadratic formula example, let's say you forget to check that it factors or not. So you forget a factor check. Which, by the way, this one does, spoiler alert. So if you forget to check to factor, and you start right into the quadratic formula, there's A, there's B, there's C, you're going to go all the way down to this. So there is a lot of information here. Let me go through and explain. I wrote down the quadratic formula because I forgot to do a factor check. I substituted all my numbers into the quadratic formula. I looked at the square root over here. Negative 5 squared is 25. When I look at the rest of these numbers, negative 4 times 6 times 1 is in fact a negative 24. So I'll be subtracting. 25 minus 24 is 1. The square root of 1 is 1. 1 is what gets substituted back into this quadratic formula. and I just realized this should be a positive 5. So this simplifies to positive 5, this simplifies to 12, and you'll notice now there's no square root. If you don't have a square root after you're done simplifying your square root, like it's all the way gone, then you must simplify. And this just goes back to me stating in all the previous examples for the quadratic formula, hey, there are really two answers here. This plus or minus means something. So if you look at the plus version of this, you'll have x equals 5 plus 1 over 12, which will be 6 over 12, which simplifies or reduces to 1/2. And if you look at the minus version of this, you'll have x equals 5 minus 1 over 12, which is 4 over 12, which is 1/3 when you reduce it all the way down. So again, we're still getting two answers, and it still works. The quadratic formula still works, even if it's factorable. So when I said earlier the quadratic formula works for solving all quadratics, it works. So just to verify this very quickly, this quadratic factors into 3x minus 1 and 2x minus 1. It still equals 0, but then we can set each factor equal to 0. And if you solve for x here, you'll get 1/3. And if you set 2x minus 1 equal to 0, if you solve that for x, you'll get 1/2. It still works. The quadratic formula is amazing because it works every time. All right, so now this is the second method for solving quadratic equations. There are, I call it 1.5 more ways to solve quadratic equations, being the square root property and completing the square, which is also very closely related to the square root property. I will be going over both of those methods in the next video. Hope to see you there.